All right, folks, in this lesson is the third half of section 10.2. And in this half of the lesson, we're talking about comparing two means, but they don't actually give you the mean and standard deviation. They give you a list of data instead. So in this case, we actually have to use our calculator to find that mean and standard deviation. All right, this study says, does increasing the amount of calcium in our diet reduce blood pressure? Examination of a large sample of people revealed a relationship between calcium intake and blood pressure. The relationship was stronger for black men. Such observational studies do not establish causation. Researchers therefore designed a randomized comparative experiment. The subjects were 21 healthy black men who volunteered to take part in the experiment. They were randomly assigned to two groups. 10 of the men received a calcium supplement for 12 weeks, while the control group of 11 men received a placebo pill that looked identical. The experiment was double-blind. The response variable is the decrease in the systolic top number blood pressure for the subject for 12 weeks in millimeters of mercury. The increase appears as a negative number. Here's the data. So they gave us the data. And we're actually doing a paired study here. We're comparing two of those. We didn't actually randomly sample two means and then got the data from two means. It wasn't randomly assigned at all. We have two different groups, and we give them two different treatments. So this is actually a paired study. So we haven't done one of these yet, so this is good. Also, we haven't done one yet that we have to find the mean and standard deviation. What's good is we can turn our calculators on, enter that data. I already have. So you turn your calculators on. Take a moment right now to enter the data from the first group with the group 1 with the calcium and the second group that's placebo. Take a minute to enter it now. I already done so. So pause the video, enter that data now. All right, hopefully you did that. Hopefully I already plugged it all into your calculator. Now, what you need to know is, because we have less than 30, we need to check to see if this graph is normal or not. So I'm going to go to second graph, or second y equals, go to stat plot, and I'm going to hit enter on the first one. Hit enter on top of on, of course, and then go over. I'll look at it with a histogram. It's kind of dark, so I hope you can see this. So I'm going to go down, and then go over to histogram, so it's entered. I'm going to use list 1 to start with. So second, then the number 1. And then I can graph. Looking at the graph, it doesn't really look like I really wanted to look, because it's just a regular graph. So I'm going to change the graph to be a statistics graph. So hit zoom and go down to zoom stat number 9. And it gives me the graph. And I don't really like how it looks there either, because I don't think it's showing me all the data. Because I'm going to change the window. So I'm going to hit window. I'm going to make sure, like my lowest number in this data set, looks to be around -4, or actually -5. So I'm going to go someplace lower than -5. So my X-min, I'm going to make it negative, let's say -8. My Y-max looks to be around 18. So I'm going to make my X-max about 20 should be good. And that should fix it. So now let's hit graph. All right, looking at it, it doesn't appear to be skewed. Not exactly normal either, but it's not skewed. So let's continue to check the second graph. So go to second stat plot, and I go over to list 2 instead. So second, number 2. Then hit zoom stat. Okay, so second, we'll quit zoom and go down to zoom stat. And this one looks closer than normal than the other one. Let's make sure our data is contained in the whole window. It goes up to about -12 and goes down to -11. So let's change my window for a moment so I can fit the whole data set. So I'll go to X-min, let's make it -15. And that should cover everything. So graph. Yeah, that looks pretty good. Looks like a pretty good normal curve. So looking at that after I adjust my window to see all the data, that's pretty much normal. So I like that one a lot. So we got enough information to say the data isn't skewed, so we can continue even though we don't have enough data points. All right, so the first question says, did the data provide convincing evidence? All right, our mission is to answer this question. Do the data provide convincing evidence that a calcium supplement reduces blood pressure more than a placebo? Carry out an appropriate test to support your answer. Then we'll interpret the p-value that we get in context of the experiment. All right, on the next page, we're looking at this. We can begin with our solution. So we're going to state using our hypothesis test. So our first null hypothesis says that the mean in the first sample, take away the mean of the second sample, equals 0, as in there's no difference in the two different drugs. And then our alternative is that the mean in the first sample, take away the mean in the second, is actually greater than 0, as in the drug actually does do better than the placebo. Or you could have said that the mean 1 equals mean 2, as in there's no difference between one and the other. Or the mean of the drug is greater than the mean of the placebo. That's an alternative way of writing the hypothesis. All right, next is our plan. After state, we got a plan. And the plan is if conditions are met, we will carry out the two-sample t-test for the difference of two means. Is it random? The 21 subjects were randomly assigned to two experiments. Is it 10%? Don't need to check because there's no sampling. So we didn't sample, we actually just assigned those men to different experiments. Is it normal or a large enough sample? It wasn't a large enough sample, but the data was close enough to normal, or at least not skewed, so we can continue using a t-test. All right, here, they're doing a do section by hand. They wrote down the n, they found the mean, they found the mean of both samples, they found a sample standard deviation of both of those, and they use the t formula here, and they use the degree of freedom that we actually have. We can use technology though. So we're comparing two means. So let's turn on the calculator. All right, so we can go to stat, go to test, and we're doing a two-sample t distribution because we're comparing two means of two different samples. And instead of using statistics, we can go over the data. List 1, list 2, and then we want to prove that list 1 is greater than list 2. Not pooled, we're going to calculate. All right, so looking at that, we have a p-value of 0.06. So looking at that, that's pretty nice to know. That p-value is 0.06. That is greater than, 0.06 is greater than 0.05. So for that reason, this is not so unusual. So in this case, we got to fail to reject the null. We got to fail to reject that the calcium and it has no difference than a placebo. So apparently, we don't have any evidence saying that they are not the same. So our next step is our conclusion. Because the p-value is greater than the alpha level of 0.05, we fail to reject the null hypothesis. The experiment does not provide convincing evidence that the true mean decrease in systolic blood pressure is higher for men like these who take calcium than in men who take a placebo. So, yeah, there's no difference between calcium and placebo. The second part of the question asked earlier was to interpret the p-value that you got in part A in context of the experiment. All right, so basically, if you want to find the means of both of those, we can go back to stat, calculate one variable statistics of list 1. Mean of list 1 is like it's 5. So mean of list 1 is 5. Do the same thing for list 2. So go to stat, calculate one variable statistics. I'm going to change that to list 2. Mean in list 2 is about negative 2.27. So the mean in list 2 is negative 2.27. That's close enough. All right, so basically, if I looked at mean 1 minus mean 2, that will equal to 5 take away negative 0.27, which is about 5.27. So that's 5.27. The question says, what does that p-value mean? Well, basically, this is what it means. Assuming that the null, that mean 1 take away mean 2 equals 0 is true, there's no difference between the two drugs, the p-value of 0.0644, there's a probability, there's a 0.0644 probability of getting a difference and the mean blood pressure reduction from the two groups, calcium takeaway placebo, of 5.237 or greater, just by the chance involved in the random assignment. As in, we could assign them randomly, and we still could have got a difference similar to that. So that's what it means. All right, let's wrap this up. So hopefully you finish the reading. This tells you more about how to use a calculator to do it. Let's talk about the inference from an experiment, as in, can we project this onto a large population? All right, let's close up this unit by talking about comparing tires and comparing workers, and talking about paired examples versus examples that are t-distribution examples that are not paired. So here's the problem. In each of the following settings, decide whether you should use a paired T procedure or a two-sample T procedure to perform the inference. Part A says, to test the wear characteristics of two brand tires, A and B, one brand A tire is mounted on one side of each car in the rear, and while brand B tires are mounted on the other side of each car. Which side gets which brand is determined by flipping a coin. This looks like it's not randomly sampling things. This is pairing one tire to the other. So let's look at a paired example. The second one says, can listen to music while working increase productivity. 20 faculty workers agree to take part in a study to investigate this question. Researchers randomly assigned 10 workers to do the repetitive tasks while listening to music, and 10 workers to do the other tasks. This would be a two-sample T procedure. The data being produced using the two distinct groups of workers is randomized experiment. And that's it. That closes up chapter 10. You can try question 53 if you want to get more practice, if you understand whether or not it's paired or not paired examples. That's all I have. Good luck.